All right, welcome everybody to the quarterly Desert Skies virtual star party. We've got some really great weather here in Tucson, Arizona. So we've got a couple of telescopes online and we're going to jump right in. And we're going to start off with Rick showing the Andromeda Galaxy. You got it, Rick.
Yeah, welcome everybody. I'm Rick Paul. I'm coming to you live from my backyard here in Tucson. And let me share what I've got going here for you. So this is the Andromeda Galaxy, is located up in the constellation Andromeda. What's going on here with my software is I'm taking pictures of Andromeda, and as each picture comes in, the pictures are stacking with each other, and each picture that comes in improves the image. We often do this with these deep sky objects, but you can see the center core here of the galaxy, and then you'll see a dark lane here and a dark lane here, and this galaxy is actually stretching from corner to corner in my frame. Andromeda is a very large galaxy. It's very similar to our own actually in structure. It's located about 2.5 million light years away, and its total width is about 131,000 light years across, slightly bigger than our own. You'll also notice there's a bright spot up here on the upper left and another one down here on the lower right. Those are companion galaxies to Andromeda. Now, our own galaxy has companion galaxies too. We just can't see them from the northern hemisphere. If you go down to the southern hemisphere, you can actually see them. They're called the Large and Small Magellanic Clouds, and they are companion galaxies to our own galaxy. They're up there too. So this is called the Andromeda Galaxy because it's located in the Andromeda constellation. Andromeda in mythology is the daughter of Cassiopeia and Cepheus. And if you've ever seen the movie Clash of the Titans, you'll know that Cassiopeia was very vain and angered the gods, and they ordered that Cassiopeia be chained to the rocks as a sacrifice to the gods. Well, Sirius came flying by and rescued her, and they got married. So that's Andromeda's story. One nice thing about Andromeda, it's one of two major objects in our sky that you can actually see with the naked eye that are outside of our own galaxy. Most of the things you see in our night skies with your naked eye are within our own galaxy. But Andromeda can be seen with the naked eye on a dark night. You'll see a little fuzzy patch up there. It's definitely visible with binoculars if you know where to look. You'll look up and you'll see a little oblong cloudy patch. You'll basically see this central core part here that is very, very bright. This was actually, it was originally called the Andromeda Nebula because it was discovered as far back as 964 BC in Persia. They noted it, and they noted it, although they didn't have telescopes, they could see it, and they noted it as a cloudy patch in the sky. And they knew it wasn't a cloud because it was there every year and it moved with the stars. It was thought to be a nebula until Edwin Hubble in 1925, using the Mount Wilson telescope in Los Angeles, actually discovered that it was in fact a galaxy like our own. And it was the first time that they had discovered that there were galaxies other than ours. So in that way, it's a very significant galaxy. It's also one of the closest galaxies to us, which is why it's so large. And it's within our local group of galaxies. So with that, remember, Jim, if you've got anything to add, otherwise we can go to Jim O'Connor.
All right, well, let me just show real quick where this is in the night sky. So if you're able to go out, if you're mobile and able to go outside at all, look towards the west and very low, not real low, but in the western horizon, you're going to see what looks like a big square. And that's the Great Square of Pegasus. It's getting a little bit low on the horizon. But if you look at the upper two stars of that square, in particular the upper right star, and you go from that star and you go up two bright ones, and then over a bright one and kind of a dimmer one. And right there is the Andromeda Galaxy. So it's just next to this star right here. And so it's an opportunity. If you've got a dark sky, you should actually be able to see it with your naked eye. So it's in the constellation Andromeda. Andromeda right now is standing on her head, and she's very close to Cassiopeia, which is the queen. This is the queen's chair right here. So she's sitting on the chair, keeping an eye on her daughter, the Andromeda. And then the king is not too far away in, right there, there he is, in Cepheus. So that's the royal family. All right, so let me stop the share here. And Rick mentioned Andromeda is in our local group of galaxies. So it's slowly drifting, we're slowly drifting together. And in about 4 to 5 billion years, the Andromeda Milky Way will merge into one huge elliptical galaxy. And we'll probably be dragging all of our satellite galaxies with us. So I think there were a couple of questions on Facebook. We'll talk a little bit about the Seven Sisters. We're getting some good information from where people are watching. That's great. Yeah, right now the only planet that's up and visible is Uranus, and it'll just show as a tiny little blue dot in a telescope. So it's not quite as exciting as Jupiter and Saturn. All right, I think Jim O'Connor's still working to get his alignment in. So Rick, are you ready to do your next one? You're muted, Rick.
Sorry, I got so many apps up. Give me just a second here, Jim. I'm almost just a few seconds, and I'll have something here to show.
All right. While Rick's doing that, let me just show you guys. We talked a little bit about the planets. Let me just show you guys where all the planets are in their orbit. So I'll do that while Rick's finalizing everything. So here is the current position of the planets. And if we zoom in, you can see in the inner solar system, between us and the sun is Mercury and Venus. So they're up in the morning sky right now. So the closest to the sun is Mercury, then Venus, then Earth, and then Mars is the fourth planet out. So these are your rocky planets on the inside. And then if we go, the asteroid belt is basically in between Mars and Jupiter. And then if we go further out, the gas giants are out here. So you've got Jupiter, Saturn, Uranus, and Neptune are the four big guys. And they are, if you'll notice, they're all on the other side of the sun right now. And that's why they're not visible right now. They're up in the morning. So the only planet that is visible from our location is Uranus out here. So it's in the process, and it'll eventually, as the Earth rotates around and puts the sun in between us and Uranus, then it'll be blinded by the sun as well. We won't be able to see it, and then it'll also transition in the morning. And then we'll have to wait until we can get some of the planets back in the evening sky. You notice I didn't talk about little old Pluto out here. Pluto is, as most everybody knows, has been degraded a little bit to a dwarf planet. But one of the reasons, if you look at the orbits of the planets, Pluto is one of the nearest objects in the Kuiper belt. And if you look at the plane of the galaxy, you'll see everybody's kind of in the same plane, except Pluto. Pluto has its orbit is adjusted. It's inclined to the plane of the solar system, and a lot of the other objects out in the Kuiper belt have this similar kind of orbit. So that was one of, some of the astronomers think that Pluto is, they call it a Kuiper belt, Kuiper object. It's the closest and the largest one we've detected so far of the objects out in the Kuiper belt. As most everybody's aware, we have the James Webb Telescope getting set up out at Lagrange number 2, about 1 million miles from the sun. And it is, when it starts taking its science pictures and does science objects for us, it may be able to detect some of the other objects out in the Kuiper belt. And we'll see, maybe it can find the elusive planet number 9 that's floating around, that they think it's floating around out there someplace. So hopefully we'll find some more objects out here in the outer solar system. So anyway, that's the current position. Rick, are you ready?
Yes, I am. So let me
Okay,
start.
you got it.
Okay, now for something completely different. This is an object inside of our own galaxy. It's actually relatively close to us, and it's called a star cluster. You'll see right in the middle here, this tight cluster of stars. This is actually referred as an open cluster, which is a loosely grouped.
Are there any comments visible?
This one is called the Pinwheel Cluster, and you can kind of see that. You can kind of see, draw some imaginary lines out in a couple of these places to kind of see a faint pinwheel design. So now you're not seeing much color here, and I don't know how much color comes across in the Facebook feed, but like this down here, you can see is like an orange-red star, and there's some things like that. All you're seeing here is like white, bluish. Well, that's the color of these stars. These are hot, young blue stars. This is in the Auriga constellation. It's a young cluster. It's only about 25 million years old, which is relatively new. If this cluster was as close as the Pleiades cluster, which most people are familiar with, you can see that in our skies very easily. If it was as close as the Pleiades cluster, it would outshine it considerably, because these stars are so bright. Let's see if there's any other notes here. Yeah, the distance to these is about 4,000 light years away, and you're looking at a structure that's about 14 light years across.
All right, you can, if you want to leave that picture up for right now, Rick. I'll talk a little bit about open clusters. So in a minute, Rick's going to show some what's called a stellar nursery, or Orion's Nebula, and there you'll be able to see stars being formed. Well, after they use up the hydrogen gas that's in the nebula, then what's left over are all the stars that were formed, and they form an open cluster like we see here. So that's why Rick was saying these are fairly young stars in the 20 to 25 million year old range. That's pretty young. Our sun is 4.5 billion years old with a B, and it's about halfway through its life. Now, large stars, if there are any large stars in this particular formation, they would probably burn through their hydrogen pretty fast, and they wouldn't live as long as our sun's going to live. But after they use up all the hydrogen gas, then they become like an open cluster, and they're kind of like a family traveling around our Milky Way galaxy. So they could take several 100 million years to make one trip around the galaxy. And as they do that, the outer stars of this family are going to slowly drift away. So they will, just like human families do, they might move to the East Coast or the West Coast or something like that, and so they'll eventually drift away from the family unit. And towards the end, there may just be a few stars left over in the core of this. Our particular solar system, takes about 225 million years to make one trek around the galaxy. So and we're about halfway out from the center. So it really does depend on how far we are from the center as to how long it takes to go around. But right now we are not in any kind of open cluster, because we've been around so long that our family members have all drifted away and are other parts of the universe or of the galaxy. What else you got, Rick? Anything else on this one?
No, I'm good on this one, Jim.
All right. So why don't we go ahead, and if you want to bring up the next one, I think Jim is still working on getting his going, so we'll just stick with you for right now.
Yep. Give me a second here. There. Oh yeah, that's looking nice. You guys are gonna like this one. Give me just a second here.
No problem.
Look pretty for everybody.
So Rick was, he started off with the Andromeda Galaxy, which is way outside of our galaxy, and then went to the Pinwheel Cluster, which is within our galaxy, and now I think he's going to hop back out again.
Yep.
Ah, look at that, looking good.
So what you're looking at here is you are seeing two galaxies at the same time, and while they look close in this picture, they are close. They're part of the same galaxy cluster in their own area. So these two galaxies are very well known. They've been known for a long time. They're fairly visible. As soon as people had telescopes, they found these. They have numbers. One is M81, the other one is M82, or Messier 81 and Messier 82. They also have names. The one on the right is known as Bode's Nebula. Again, early on, they didn't know these were galaxies. He just saw a fuzzy patch up there and called it a nebula, but it's still kind of colloquial called Bode's Nebula. The one over here is called the Cigar Galaxy. We're seeing it kind of edge on. It's also, when more high resolution pictures have taken of this galaxy, it's been a little perturbed, and they think that these two galaxies had a close encounter at some time in the last couple million years. This one came over and kind of came close to that one and perturbed it a little bit. They are both about 12 million light years away, which is relatively close for a galaxy to us. Some galaxies are more on the order of 40 or 50 million light years away that we can see. So these two are still reasonable. And they're both in the medium size of galaxies. They're about 73,000 light years across. If you remember, Andromeda was about 131,000 light years across. And Jim, if I'm correct, I think we're at about 110, 115,000 light years across for ours.
Yeah, so that's pretty close. Yeah.
Yeah. So these are on the medium side of galaxies. So that is M81 and M82, two very nice. And these are located in Ursa Major, up in the Big Dipper. So they're visible all year round. They're all, because they never set. They circle around the North Pole.
Yeah, and I'll show you here in a minute where they are in relation to the Big Dipper. But as Rick mentioned, you get two views of how we normally will see spiral galaxies. We have a pretty close, full-on face view of Bode's M81, and then M82, the Cigar Galaxy, is an edge on. So we're looking at the edge of the galaxy. So if you think about it, just like as I was showing in our solar system, everything's kind of flat, and because everything's got an orbital motion to it. Well, the same thing happens with galaxies. They're fairly flat as well, as is our Milky Way galaxy. Our galaxy is roughly, as Rick mentioned, about 110,000 light years across. We're 26,000 light years from the center, which would put us about halfway out. The Milky Way is 110,000 light years across, but it's only about 1,000 light years thick. So you think about that, it's not very thick. And that's why we're seeing, when we look at the edge of the galaxy, of the Cigar Galaxy here, that's why it looks so skinny. And you're looking at all the starlight concentrated on the edge of the galaxy. So sometimes you can see the dark dust lanes going through. You can see the core of the galaxy fairly well, as you can see the core on Bode as well, on Bode's Galaxy Nebula. It's right in the center. So probably, you know, a quarter of the stars are probably focused in that, concentrated in the core, and then the spiral arms, and you can see the orbital motion of the galaxy as it's rotating. You can see the spiral arms going out.
One thing I was going to note, where Bode's is kind of unusual from a lot of the galaxies we see. A lot of the galaxies that we see face on like this, we can see the arms, and we'll see several arms, a lot of structure in it. Bode's is unusual that it has these two distinct arms. You'll see one on the bottom here and one on the top. So it's kind of unusual in that aspect, unusual appearance to us, at least, of what we can see in its structure there. You want me to go to another one, Jim? I got my next one up.
Now let me show them where we're looking first.
Okay.
So here we are. It's the wrong one. Never mind. Wrong share. Let me bring up a different share. Make sure that you're seeing it. So you should be seeing Ursa Major right in the center. And Rick or Jim, if you're not seeing that, by all means, let me know so that I can correct it. So this is looking off to the north. So pretty much north to northeast. And everybody's familiar with the Big Dipper. Right now, the handle of the Big Dipper is pointing down, and you've got the bucket, you know, probably not too far above the horizon, at least here in Tucson. The further north you go, the higher up it'll be in the sky. One thing to note is the two end stars of the bucket of the Big Dipper always point to the North Star. So if you follow those two stars out this direction, you can see it points right to the North Star, which is the end of the handle of the Little Dipper, or Ursa Minor, the Little Bear. And it comes down, and most people in their skies can see the Polaris and these two end bucket stars. If you can see the other two bucket stars and the two handle stars, then you've actually got really good skies. This star right here on the bottom of the bucket is the dimmest of all of them. If you can see that one, then you've got some good skies. So going back to Ursa Major, the two galaxies that Rick showed, M81 and M82, are just off the bucket. So if you kind of come out of off the bucket, they're kind of up in this area. So they're towards the head of the bear, and that's where they're located, right in there. All right. You can also see this just coming up right now. A little bit further to the east is Leo. Leo means lion, so some people will say Leo the lion, but that's kind of redundant because that's actually just saying lion, the lion. But Leo is you can usually recognize its name by a backwards question mark. So you can see the question mark here and coming around this way. And that's the name, and then the body is pointing down below. So that's just now coming up in the east. All right, Rick, let's go to the next one.
Yeah, so this one I'm going to show you now is what I would call the showstopper of the season. This is something everyone looks forward to seeing every year when it comes up. There we go. This is
gorgeous.
referred to as the Great Orion Nebula. This nebula is very close to us. That's why it's very large on my display here. I'm not zoomed in at all. This object is fairly large in our sky. You can actually see the Orion Nebula with the naked eye. You've looked at it your whole life and probably didn't even know that's what you were looking at. When you look at the constellation Orion, you'll see the 3 stars of his belt going across. And Jim will show you this in a minute when I'm done. And then there's 3 stars of his sword dropping down from that. Well, the 3 stars of his sword are actually this nebula complex here. The middle one you'll see is, when you look closely at that sword, you'll see that middle star is kind of fuzzy. Well, this is what you're seeing here. It's very easily seen in a pair of binoculars. Very easy to spot with binoculars. Now, what you're looking at here is a stellar nursery. This is a cloud of largely ionized hydrogen gas, and that gas is collapsing down into stars. And this bright, overblown section here is where there is baby stars being formed, very new, bright, hot stars. And to show you how bright this object is, those galaxies I was showing you, I was doing 2-minute exposures to get those galaxies. Here I'm doing 15 seconds, and those stars are blowing it out. They are so bright. So some more statistics on this is it's relatively in our neighborhood. It's 1,400 light years away, which might seem far, but in stellar distances, that's pretty close. Because it is so close and it is an active star forming region, it is highly studied by astronomers because of that. That study stellar formation, they like to study this in more detail. It's about 35 light years across. So again, a very large structure. We're a planet orbiting a sun like one of these stars here. So we're just a little tiny thing. This thing is just gargantuan. One thing to note here, you can see the structure in these clouds here. Almost looks like a sunset with clouds on Earth in the structure. And then down here, you'll see some dark stuff. That is interstellar dust, usually composed of frozen carbon dioxide molecules with dust particles that creates a very light absorbing material. And that's what creates that dust. Now over here is another, we get a little bonus nebula here. It's a little nebula over here, and it's called the Running Man Nebula. And if you look not at the nebula, but in the shadows in the nebula, it looks like a little guy. You'll see his head here. There's an arm coming back there, an arm coming out there, a leg coming down there, and a leg coming down there. So once you see, you can't unsee it. That's the Running Man. So this is Orion and the Running Man.
Yeah,
Jim, you want to show them where these things are now?
Yeah, that's a great view. I was down south of Tucson last night doing a star party, public star party at Canoa Ranch, and I showed Orion, and the nebula just filled up the eyepiece. It was just gorgeous. You don't see the colors like you do with the camera when you're looking through the telescope visually, but with the Orion Nebula, you can clearly see the cloud of hydrogen gas. It's kind of hard to pull out here in the middle, but there's 4 stars really close together that we call the trapezium, and those are some of the baby stars that were born in the nebula. Now I say baby stars; they're probably several million years old. They might be probably 6 to 10 million years old. But there's some of the larger stars that are formed right now in the nebula because they have so much gas available to them that they can grow huge, and so they're gonna pretty much party hardy and die young. Large stars do not last very long, and they quickly burn through their hydrogen and become unstable. And if they're at least 8 times the size of the sun, when they do that and they become unstable, they go supernova, they explode. So they'll compress down, and then the rebound effect, and they kind of blow off all their gas. But that's a good thing in that they are seeding some of the heavier elements that we have here on Earth and that we use, gold, platinum, aluminum, all the heavier elements basically beyond iron are seeded when this happens, as well as the neutron stars. And it just happens during the very end of the life of these stars. And so that material will get blown out into this nebula and will be available to be used for other stars as they're born in here. So it's kind of cool that, and once all the stars are born and they use up all the gas in here, then they will become an open cluster like the Pinwheel Cluster that Rick showed earlier, And another cluster that that someone mentioned on Facebook, the Seven Sisters, which is also called the Pleiades. And it's an open cluster of stars that were probably formed out of the same nebula way back when, and they are traveling around the Milky Way galaxy together. And the cool thing about, and you can look up right now, it's pretty much straight up in the sky, almost right up at the zenith is where the Pleiades is. And it kind of looks like a little baby dipper. Sometimes people will confuse it as the Little Dipper, but it's not. It's in the shape of the Subaru logo, car Subaru logo, minus one of the stars. They only have 6 stars on the logo. So, and in fact, Japan calls the Seven Sisters Subaru. They call it the Subaru cluster. So when you get an opportunity, if you want to go outside and look straight up, you'll see the Seven Sisters focusing out there. Anyway, let me show you where we're looking in the night sky for the Orion Nebula. So now if you go outside and were to look towards the south, you'll clearly see Orion off in the distance. Zoom in here a little bit. You'll see a red supergiant star called Betelgeuse right up here. Betelgeuse, however you want to pronounce it. It is a red supergiant, so it's a huge star that they're predicting will probably go supernova in the near future. All right, so what does that mean? Well, that means the Betelgeuse is, let's see, it is, how far away is it? It is about 650 light years away. So if it blew up 649 years ago, we're going to see it next year. So, or it could blow up now and we'll see it in 650 years. So, or it could blow up, it could go supernova in 1 million years, but it's getting close to the end of its life. So probably 1 million is as far out as it's likely going to go. But it's really close to going supernova. And there was in the news a year or two ago when it got, I think it was last year when they said it got really dim, and they were thinking that something maybe was about ready to go supernova, and it was in fact just a heavy dust going across the face of the star, and it caused it to dim down. So that's in the upper right shoulder of Orion, and his left shoulder, you look just straight across, and there's another star over here, and that's his left shoulder. And then down here in his feet area and knee, this star down here is a blue supergiant called Rigel. And then in between,
sorry, could you say that again?
And then in between, you'll see the 3 stars in a row, and that's the belt of Orion. Well, as you look below the belt, down in where his sword is going, that's why we call it the Sword of Orion, you're going to see what looks like 3 stars, kind of a diagonal from the belt that look like 3 stars. Well, if you look carefully, the top and bottom stars look like stars. But if you look really carefully, the center one is a little fuzzier. And it's fuzzier because it's not just one star, it's the nebula. And it's all the stars that are inside the nebula. So it's going to look a lot different and things like that. So that is Orion, and Orion is one of the more famous constellations when you look to the south. Just above it, while we're waiting for Rick to get his scope ready for the next one, just above and to the north of Orion right now is Gemini the Twins. And you can see 2 bright stars, one on top of the other one is Castor and Pollux. And they're the heads of the 2 twins. And then they're kind of laying on their sides. Their bodies go to the right or towards the south. And then you can see their feet down here. Castor is a really fun one to look, star to look at in the telescope. It's I showed it last night as well. And it's a 6-star system, but we can only see 2 of the stars. We can't see all 6 of them. But the stars are fairly close together. They're it's what's called they're 80 astronomical units apart. And what we call an astronomical unit is the distance between the Earth and the Sun, which is 93 million miles. So it's 80 times 93 million. So that puts it out, you know, a little bit beyond Pluto, but probably still within our solar system. Those two stars and plus the four other stars that are there as well are, you know, so it's fairly crowded in there. I don't recall if Castor has any planets around it. You get that many stars and it's kind of tough for planets to form because there's a lot of gravity happening, and you know, a lot of the material was used up by the stars, and so there wasn't much left, and so it's really hard for them to stay into a stable orbit. But that's Gemini the Twins. We did have a question of talking about the equipment, and so Rick, we'll do that next. Before we go to your next object, I will show you your equipment, and you can talk to it a little bit so that you guys can see what kind of camera that he's using. But so yeah, so that's looking off towards the south. So let's see, I'm gonna stop the share here. And Rick, are you ready to talk to your equipment?
Yes.
Okay, let me get it brought up here.
Oh, hold on just a second, Jim.
Okay. So yeah, we talked a little bit about the Seven Sisters, you know, and we've been talking about distances, and you know, it's you know, when we do astronomy, and I tell the kids this when we're doing it with some young kids, that you're in essence you're a time traveler, because when you look at an object, let's say the Andromeda Galaxy, 2.5 million years away, 2.5 million light years away, you're looking back in time of what that galaxy looked like 2.5 million years ago. So, so you know, even though that's just kind of a snapshot in time and a short distance of time, it took that photon, that light, when it left the galaxy, it took 2.5 million years to get to your eyeballs. And so that's so, you know, again, not a lot changes in 2.5 million years in the big scheme of things, but sometimes we'll look at galaxies that are, you know, 50, 60 million light years away. Now, if you were to look at a galaxy that's roughly 60 plus million years ago, or a million light years away, you're looking at what that galaxy looked like when the dinosaurs were roaming Earth. That's when that photon of light left the galaxy, and it took 60 million years to get to your eyeballs. So again, you're looking back in time at what it looked like. So that's kind of cool. All right, Rick, you ready for your equipment?
Yes.
All right. There it is.
Yeah. So this is what it looks like in the daytime setup where I set it up in my backyard. What you're looking at here is a 4-inch refractor telescope. It uses lenses to magnify the image. This is the oldest type of telescope. Of course, my lenses are a little bit. Now, what you've got on top of it here, you'll see a little telescope up there with a little red cylinder on the back. That is what's called a guide scope. Provide that information to the computer, and the computer is what's doing what's called keeping focus single star and micro commands to keep the mount aligned over long periods of time on one object. So the stars don't. My astronomy camera hooked up to the back to that other red cylinder. In this configuration, this is actually my monochrome astrophotography camera. So what's connected to it here, this put different filters in place so I can get the same way as the Hubble Space Telescope does. It's got a monochrome camera and uses filters to then build up an image. and then I'm here on a big, which keeps me aligned and very stable.
All right. Thanks, Rick. Very good. So you're about ready. I think Jim's still working on his. So we'll just keep
Hey,
going
Jim?
down your list. Yeah.
Jim, I can go over mine now. I just finally got the problem solved.
Okay. So yeah, if you want to do your first one, and then we'll hop back.
No,
to
I mean,
Rick.
I haven't gotten to the object yet. I just finished the polar line.
Okay.
I can talk about the scope.
Oh yeah, yeah. Let's do that. Hang on just a second, and let me get it up. All right, should be coming across now. Go for it.
Okay, that outfit you see in the daylight is what I'm sitting at right now, with one exception. On the left-hand picture to the left of the scope is a monitor. That monitor there was 17 inches. I'm using a 24-inch monitor right now just because it puts out a little easier picture for me to work with crowds. But you're getting these signals off of a laptop, so it doesn't matter. The telescope itself is about a 30-year-old Meade 10-inch Schmidt Cassegrain. I've had it rebuilt one time, and it's on a relatively new Celestron German equatorial mount called an AVX. The camera I'm using, you can see in the right picture, is stuck in the back of a telescope, just like a instead of an eyepiece to do that. The camera itself is a Mellencam Exterminator 2, and it's sort of like a baby camera compared to Rick's, because it's only got 377,000 pixels. So it has a smaller chip, but that means it's fast. It can get the image fast, despite what tonight has been happening. The camera works very well. The weight of it all, the telescope itself weighs about 31 pounds, and the balance weights at the bottom are they're about 29 pounds of balance weights. And it takes me about 45 minutes to set up usually. So that's what I'm going to be, in a few minutes, I'll be bringing you images from.
Excellent. Well, thanks, Jim. Yeah, so that's good. So we'll go ahead and we'll have Rick do another one while we're waiting for yours to get ready to go, and then you can just let me know, and we'll hop over to you next. So, Rick, you ready?
Not quite. I need a few more minutes, but I can start talking about it here in a minute. Just let me make sure.
Okay, no problem. You muted yourself, but that's all right. So if you want to just bring things up, I'll chat a little bit while we're waiting to get there. So again, we've got some nice clear skies here in Tucson, which obviously are important to doing astronomy. But the other part of doing astronomy is having some dark skies. And we're fortunate that we have some decent lighting ordinances here in Tucson. We're starting to get a bit of a light dome, but it's still pretty good for a city of 1 million people. We're able to have fairly reasonable dark skies. Our club, the Tucson Amateur Astronomy Association, which is the club here in Tucson, we have about 500 members. If we want to do any serious dark sky observing or imaging, the club has an astronomy complex about 100 miles southeast of Tucson near the Chiricahua Mountains. And so we'll go out there. We have some observing pads with electricity that the members can set up their telescopes. We have several club telescopes out there. So if you don't have one or don't want to bring your personal one out, you can use one of the club telescopes. We're also in the process of putting in some sleeping rooms and some other amenities to help accommodate overnight stuff. One thing we're working on right now is a learning center so that we're able to, in the near future, hopefully bring school groups and youth groups out to experience the dark sky, and to be able to, we'll have some telescopes set up with cameras on them that we can let them use, take pictures of some objects, and then maybe go back to school afterwards and do a report and show the picture that they observed. So we're building a pretty good complex out there, and it's going to be a lot of fun once we get it fully operational. We had some members that donated the land back in 2008. So since 2008, we've been slowly building it up. We have a large 40-inch Dobsonian type telescope out there. When I say 40-inch, that's the size of the mirror that it uses. So that's 40 inches in diameter. So that's a little over a meter in size. And then we also have a nice refractor and some other telescopes out there. So it's a great opportunity to do some events out there. And we usually open the site several times a year for the public to be able to come out and experience it. So that's where we end up going if we want to get some serious dark skies in. But we're still fortunate here in Tucson. We have pretty good skies. Rick and Jim are able to image and do their thing right from their home. All right, Rick, you ready?
Yeah, I can start talking about it.
Okay.
The image is still coming in. This is a much longer exposure. I told you guys earlier that the Orion Nebula was only like 15 seconds. What we're going to be looking at now is a much larger object, even larger. It's actually 5 times larger than a full moon in our sky. It's just such a dim object, we can't see it with our naked eye. But it takes 300 seconds to get an image. So we're about halfway through that right now. So it's coming in. What you're going to be looking at here in a few minutes is called the Rosette Nebula. It's located just east of the Orion constellation. It's very close by there. It is a vast cloud of again hydrogen gas. Again, was a star forming region, a little bit older of a star forming region than Orion is. And you'll notice when you see it that it's going to have a hole in the middle. And that hole is caused by the stars that were born in the center of it. And they're throwing out a lot of solar wind coming off of it. And it's blowing the gas out. So it's created a donut shape. So let's see where we're at here. We're about 1 minute away from having an image. So just bear with me here a little bit. The Rosette Nebula is about 5,000 light years away. So it's a little bit further away, but again, it's further away than the Orion Nebula, but you'll see how much bigger it is, even though it's further away than Orion is. The structure you're looking at is 128 light years across. That's in comparison to the Orion Nebula being only 35 light years across. So it's a good 3 to 4 times larger in diameter. And let's see, about 15 more seconds here, and we'll have something to look at.
If you want, I can show them where it's at, or are you about there?
Yeah, it's coming up here.
Okay.
Oh yeah. So let me start sharing here. And I'll actually step you through a little bit of the process I'm doing here. So there it is. This is the first image in, but you'll notice that it's black and white. That's because this is the raw data coming in from the camera. The computer has not done anything to this raw image yet. So in my software here, I've got to tell it that, yes, this image is color. That's the RGB pattern of the matrix on the sensor. And I want to start watching this folder, and it's going to go and process this image and convert it to a color image for us. and boom, you've got some color. Mostly reds, a little bit of green in there. And you'll see why it's called the rosette. It's kind of almost got this petal look to it as it goes around. Here's that center open section, and these are the stars in the center that are blasting out that solar wind, driving it out. You'll also notice some other structure in here, so dark structures again. Those are those dark dust lanes of frozen carbon dioxide that are blocking it. But you see how large this object is. And this is my uncropped camera sensor. This is exactly what my camera is seeing. If I focus this on the full moon would only be occupying about the same area as that center section of the nebula there. So that's how large this object is in our sky. It is absolutely enormous. Not visible with the naked eye, not visible with binoculars, not even easily visible with a telescope. For many years, all that was known was this cluster of stars in the center, and that cluster of stars has its own designation. That's what they saw. It wasn't until the early attempts at photography and longer exposures that they were able to see this object really as the nebula that it is.
Yeah, that is absolutely gorgeous. It looked good even in black and white, but then when the colors pop, you can really
it's really an
see some
object.
depth.
Often what astrophotographers will do is, here we're giving you 1 or 2 images stacked to do this. What we really like to do is image this over all night, get 5, 6, 7 hours of it, or even do it over subsequent nights. The more images you have, the greater detail you get, and the better signal to noise ratio you get of the target you're getting against the background. So this is an object that definitely benefits from longer and longer and more exposures.
Yeah, that is absolutely gorgeous. And yeah, like Rick said, it's a tough view through an eyepiece because it's just so faint. You really need to have the camera to bring out the depth and the faint photons, as we call it, and make it so you can see it. So I'm going to show you where.
Go ahead. Well, also tell you there was an object that I had to skip because it was getting too close to what we call the meridian. It's the north-south line running through the sky, and when our telescopes get to that point, they have to flip around to get them. They can't track all the way across through that. So it was getting a little bit close to that, so I had to skip it, but I may be able to go back to it at the end here. But yeah, go ahead and show them where it is, Jim.
All right, so as Rick mentioned, it is just to the north or left of Orion. So here's Orion again. It's in Monoceros, the unicorn. I guess that's a unicorn. Kind of looks like a unicorn. And it's right as where his nostrils are, where his nose is. And so if we zoom in, we can see that that's where it's at.
Yeah, I never noticed that, but you could almost say that central opening there is his nostril.
There you go. There you go. And so while Rick's getting set for his next one, I'll just talk a little bit more about what's up in the night sky. If you go out and look down towards the south, you can see Canis Major, or the big dog. We talked, I think Susan mentioned on Facebook, Sirius being the brightest star in the night sky for the northern hemisphere anyway. And that is, sometimes you'll hear people refer to Sirius as the dog star. And that's because it's in Canis Major, or the big dog. So it's in the constellation of the dog. And it's one, if you look at it, so you're looking towards the south. He's kind of sitting on his butt, so he's pointing up. And so his body will flow down towards the horizon, and you'll be able to see his legs coming off to the right as you're looking at it. And it actually does kind of look like a dog. And there are some, if you've got some decent skies, you might be able to even see the tail back here. There's some of these constellations that you look at them and you go, nah, I don't get it. Where did they come up with this? But Sometimes they had much darker skies to help them along. But that was, so that's Canis Major. And right now, at least from Tucson, and if you're in probably our latitude or lower, you'll probably be able to see it. If you're much higher than Tucson, you can't. But if you have a good, clear view of the southern sky, I don't think it's going to show up on here. If you look down towards the south, you're going to see another bright star, maybe about 10 degrees above the horizon, almost straight south. So it's going to be below Sirius and to the right a little bit. And that is a star called Canopus. Maybe this is it right here. Yeah, this is Canopus right here. So you can see that it's just barely above the horizon. Canopus is the second brightest star in the night sky following Sirius. So it's going to be very bright on the horizon. And we can only see it this time of year, and it doesn't get very high from Tucson. So if you're much higher latitude than Tucson, you won't see it at all. It's really a southern hemisphere object. If you were down on the equator, it would be much higher. And but that's kind of cool to be able to look at that. And that's another huge star. It's minus 0.65 in magnitude. And let's see what the distance is, 309 light years. So it's about twice as close as let's see, no, Sirius is 8.6 light years away. So Sirius is, almost 9 light years away. This guy is just a little bit dimmer than Sirius, but it's almost 310 light years away. So you think about it, that star must be huge and bright, to almost be as bright as Sirius and be that far away. So, a lot of times, we just go out in our backyard with a pair of binoculars and, you get one of those 0G chairs where you can lean back and comfortably look at the night sky. And you just sit back and watch the satellites cruise overhead, or, you can look for some meteors. And, I think most everybody knows meteors are just specks of dust. They're grains of sand, the ones that burn up very quickly. There's really not much to them, and they're leftover debris from asteroids and comets that have flown through previously, and the Earth is then going through it. So that causes meteors.
I want to add to what you were saying, Jim, there, and again, encourage everyone to go out at night, especially on a no moon night, sit back in an easy chair and look up. And if you own a pair of binoculars, take them out and look around. I think you might be surprised on what you stumble on, because many objects up there are visible in binoculars. Things like some of the larger star clusters, and even some of the brighter nebulas and galaxies are visible with binoculars. So you might be surprised what you'll see. And if you have, you get one of the free Astro apps on your phone, that'll help you find things, or if you find something, it'll help you know what you found.
Yeah, another one that if you've got decent dark skies that you can, it's called the double cluster in Perseus. So here's Perseus up here, kind of standing on his head just above Cassiopeia. So we're looking now towards the west, northwest. And the Cassiopeia is a fairly familiar W or M kind of shape. That's the chair of the queen. The very, if you see the very steep triangle, and another way to find Andromeda, I'd mentioned earlier, you can come off the great square of Pegasus and this upper star, and you go up to and then over to, and it's right in here. Another way to find it is off of Cassiopeia. The steep triangle right here almost points directly at it. It's a little bit high, but it almost points directly at the galaxy right here. But and so that's a way, if you're able, if Andromeda is the furthest object we can see with our naked eye from a dark sky. So that's 2.5 million light years away, and it'll just show as a little hazy patch. But what I was about to say was in Cassiopeia up here, if you go off of this flattened triangle, and these N2 stars, if you make kind of a steep triangle up here towards the head of Perseus and then back down again, right up in here, you'll see a fuzzy patch, and that's called the double cluster. And that's two open clusters of stars that are, moving around the galaxy. So they used up their nebula a long time ago, and they're open clusters, beautiful in an eyepiece. I showed those again last night as well. And I could barely get both clusters in the eyepiece, but it just filled the eyepiece full of stars. And that's a gorgeous sight. From a dark sight, they almost bring a three-dimensional view. But you can see that if you've got good skies, you can actually see that as a hazy patch. You just kind of make a steep triangle from this flattened part there. All right. Rick, you ready for another one?
Sort of. Again, I can start talking about it. We're about, this is another long duration one, but I'm about, well, I'm only 20 seconds away, so I don't have to stall for very long.
All right.
It's also something I've
like,
never imaged before, so we're all going to be surprised by this one.
Yeah, Jim's still having problems with his, so if you've got any other objects beyond here, we'll just keep going, and when we run out of things to talk about, we'll call it quits.
Jim, if there's been any special requests for any objects, I can take those into consideration.
Yeah, M45, the Seven Sisters was the only one that kind of came up if you want to try that, but it's right up at the zenith.
Oh, but this one's, I think everyone's going to like this one.
All right.
Let me get it up here. Hold on, everybody. I'll have it for you in just a second, but trust me, it's worth the wait. Okay, I'm going to share now. Okay, so this object you're looking at is, it's known by two names. Its oldest name is the Duck Nebula, but its name in more recent times is Thor's helmet. So yes, you're looking at the helmet of Thor, the god of thunder. There's his little wings coming off his helmet right there, and there's the helmet part right there. You're seeing a green nature in this more than it actually normally looks more like kind of bluish. My filters just make it kind of greenish. So it's not as rich in hydrogen gas. It's more in the sulfur gas region. But this is located up in Canis Major, where we've been recently for some of the evening here. This structure is what's known as an interstellar bubble. There's another nebula called the Bubble Nebula, which looks like a bubble too. It's being blown apart like this because of a very bright central star, which is a very rare type of star. It's known as a Wolf-Rayet star. Wolf-Rayet stars are extremely massive giant stars that have very short lives. They burn fast, and they go supernova. This one has not gone supernova yet, but it's very, very hot, and it's so hot and so massive, it's throwing out its outer layers. It's throwing them out at a rate of thousands of kilometers per second. It's just throwing this stuff out, and that's what's creating all this debris you're seeing out here. And this is all being lit by that very bright star in the center. So a very fun object to see. Nearby to this is another nebula right up here called the Seagull Nebula. And with a little bit of patience, Jim, I might be able to pull the seagull into here.
All right. Yeah, I mean, that one does actually kind of look like Viking Thor's helmet, you know?
Yeah, it really does. It's one of the ones that actually looks like what it's called. Let's see.
Well,
And
if you
Jim
want,
O'Connor, I don't know if you've got anything to add about the Wolf-Rayet stars, any of the knowledge you have on them.
Yeah, Wolf-Rayets were kind of rare or unknown until probably about 30 or 40 years ago. And then they began to notice that there were very odd things about them. The trouble with the interesting feature of Wolf-Rayets, and you might have mentioned it, but I didn't hear it. I'm still trying to bring order out of chaos here. The interesting thing about Wolf-Rayets is they're so big that their solar winds actually can drive some of their own mass away and then falls back in too fast. And it makes the diameter decrease a little bit, and it almost goes into a mini nova, and it starts throwing pieces off. The result of all that is odd radiation for a star, if you really look at it. And let's say 25 years ago, when I first got involved with doing something in this passionate sport, there was only one known Wolf-Rayet star. And now they found quite a few of them just by closely looking at the electromagnetic radiation coming off them. But the main feature of a Wolf-Rayet star is this pretty doggone massive. And the mystery is, why doesn't it just go supernova?
Yeah, very nice. While Rick's tweaking that a little bit to see if we can bring anything else out, I will show you where in the night sky this is located. Bring up Stellarium. So the program I'm using here, which is actually a free program, you can download it from stellarium.org. That's STELLARIUM, and it allows you to see, the night sky from your location and zoom in and out, whatnot. So Thor's helmet, also known as NGC 2359, as Rick said, it's adjacent to Canis Major, which is the big dog. So again, that's Sirius right here. And you've got the body of the dog down below it. So it's just to the left of that, in between Canis Major and Monoceros. And as we zoom in, there it is. Oops, I go out that far. Getting dizzy. So we're looking basically to the southeast is where we're looking at there. Rick, we did have a request for the Horsehead, if you're able to do that at some point.
Let's see. It's 8:09. It is just past the meridian. Let me do the Seagull first, and let's let the flame and the Horsehead get a little bit further past, and I'll definitely go back to that.
Okay.
So give me a minute here, and I'll have the Seagull up.
And which constellation is that in? Do you remember?
It's really close to Thor.
Okay, so it's still in this general area.
It's between Monoceros and Canis Major.
Okay, so it's same basic area. All right, well, Rick's doing that. We'll just kind of do a little more exploring around the night sky. Let me shift my time up a little bit here so that it is a little more reflective. So we'll go up to roughly about 8:15 or 8:20. So this is what the sky should look like right now, at least from the Tucson area. Again, looking east, Leo's gotten a little bit higher. You can certainly see the Big Dipper's up a little bit higher. So you're starting to be able to see more of the handle of the Big Dipper. One of the cool stars I do like to show in a telescope is Mizar, which is the star right here at the curve of the handle of the Big Dipper. It's a multiple star system. When you look in the telescope, you see two stars really close together, Mizar A and B. And each one of those stars has another star associated that we can't see. And then if you look close enough, let's just zoom in here a little bit. If you look just with your eyes, you can look off to the lower left, you'll see another fairly bright star, and that's called Alcor. A lot of ancient peoples would use this as an eye test to test their warriors or their tribesmen, their eyes, to see if you could pick out that second star. Your eyes were good enough. In actuality, it's not that hard to see. So most of the warriors passed just fine. But they did use it as an eye test, and that's in the handle of the Big Dipper. So that's a really fun star to show through the telescope as well. As is Castor. We talked about Castor before. Where'd Castor go? There we go. So in Gemini the Twins, Castor is a multiple star system as well. So it's a 6-star system. So it's got the 2 stars you can see. And I don't think I mentioned the 2 stars are. So Castor is, let's see, it is about 52 light years away. And the stars, like I said, are separated by about 80 astronomical units. So 80 times the distance from the sun to the Earth to the sun, which is fairly close for as far as stars go. And they take, those 2 stars that we can see take about 450 years to make one orbit around each other. So if there were planets around this system, which happens to be a 6-star system because there's 4 stars we can't see, if you're on a planet around one of those stars, you might have 6 suns in your night sky. Of course, some of them might be, down below the horizon, so you might never have darkness, or you could have, multiple ones in the night sky, and they're going to be different distances away. But that would probably be not so good for astronomy because you'd have a lot of brightness. It might be tough to get some dark skies. Let's see. There's lots of galaxies in Leo, which is kind of fun to look at. You can look at, an eyepiece or a view through a camera. You can see, lots and lots of stars. You can see here that's just showing up the Leonids, which is a meteor shower that'll be taking place here pretty soon. And so that's and the way meteor showers are named is they're named for the constellation they emanate from. So in this case, the meteors will appear to come out of Leo. So, they'll tell you if you're going to go out and observe the meteor shower, if it's the Leonids, you want to make sure you've got a good view of Leo. But you don't want to just focus on that area. What I usually do is I will kind of look at the constellation that they're emanating from, but I'll use my peripheral vision to keep an eye up on the night sky all around me, because you'll see them coming all over the place. But they tend to emanate from that constellation, and that is happening as the Earth goes through this debris field from past comets and asteroids. Each time of the year that as we go around the sun, we come back through this debris field the same time each year, and that's why the meteor showers are the same time frame each year. And it's going to vary some how much you can see depending on whether you've got a moon or not. If you've got a bright moon out there, then it's going to wash out a lot of the fainter meteors, and so you may or may not see them. How you doing there, Rick? You ready?
I am within 2 minutes of being ready.
All right. Well, I'll keep chatting then.
Another dark object. So.
Okay.
But I can start talking about it. I've already mentioned we're going to be looking at the Seagull Nebula here. If you could see the whole thing, it definitely looks like a bird head with wings stretched out. We've been talking about the size of objects. This one is beyond massive. I would put it in the realm of gargantuan. It is so large I cannot fit it on my image sensor completely. I'm only getting about half of it. It's so big. But we'll see the head and some of the wing structure. Again, it's constellations there. It is about 6,000 light years away, so similar distance to some of the things we've been looking at. But it is 107 light years across. So for nebula-wise, this is by far the largest thing we've looked at. It is just huge.
It's kind of on the screen
large,
right now.
Hydrogen gas region. Again, it's a star forming region. Let's see, we're almost there. Give me a second here.
So it looks like it's right off the head of Canis Major. So again, in the same general region that we were looking at the Rosette and some of the other.
There we go. Just give me 20. There it is. Okay, let me share. Down there. And again, these wings go off the edge of my screen. Even this thing is just so massive. You remember how big Orion was? Again, the image, you know, was that big, and Thor's helmet was like that big. And for reference, they're pretty close together. So again, showing you some different nebulas tonight. You're seeing different structures around them. This is just caused by how the gas is coalescing in space, how these gases have come together, the influences of the stars and other large objects around them influence how these things come together. Again, this is an older region than Orion. That's why it's gotten more diffuse like this. But that is the Seagull Nebula. And next up here, Jim, in a few minutes, I'll have the Flame Nebula, and the Horsehead.
All right, now Rick, I don't think you ever shared your Seagull.
Oh, I'm sorry, I didn't hit the final button there.
Do you want to bring it up, or is it too late? Is it gone?
No, it's coming up.
Okay.
Oh, wrong screen. Let me try that again. Sorry, everybody. I thought I'd hit that share button. You were looking at nothing. There we go. Yeah. So again, here's the head. There's the wings going across diagonally here, the body coming down here. And the Thor's helmet is that away, down there towards like where the timestamp is down here. It's down over there. But again, a very, very large nebula. Again, Orion would just be about this central area here in size. Things again, it's 200 light years across, just very, very large.
And you can see some of the dark dust lanes kind of creeping through like the head of the Seagull there. You can see one that's going through there. And so what that is that's just heavier dust and gas. And so the starlight from behind it is not allowing, it's not being penetrated through. And so it's showing up as dark, we call it dark nebula, but it's that's another thing that we can look at. You can see another nice patch in kind of the right wing of the
what I was going to point out to everybody is sometimes the structures we see that is the natural arc of the gas we're seeing. Other times, it could be that there's dust between us and it, and these stars you're seeing here are actually between us and the nebula. So that star may be closer to us rather than behind the nebula. But in this case, like the head here, you can clearly see it's a dark lane blocking the dust blocking the gas behind it.
Very nice.
So give me about, it'll take about 4 or 5 minutes and I'll have the Flame Nebula.
All right. Well, let me,
And the Horsehead, they go together, they're a pair.
yeah, okay. And then we'll probably start winding down here pretty soon, but we appreciate everybody hanging in there with us. Rick's been doing a fabulous job of bouncing between objects.
Well, Rick's been rescuing me.
That's all right. You know, this
Yeah.
equipment can be a little technical at times and be a little persnickety, as we say.
Well,
Sometimes it works.
yeah, I've been
and
lucky
sometimes it
tonight.
doesn't.
Everything's been working really well. I was out last night and I had a few problems last night. So, you know, this is all a lot of, you know, what you're not seeing here is I've got, you know, I've got a telescope mount. I've got the 2 cameras running. I've got 3 pieces of software all trying to work together. And there's other pieces of software in the background too that are doing all of this. So sometimes one of those pieces of software decides to hiccup and things happen. So.
Well, Jim, do you want to talk a little bit about the night sky while Rick's bringing up the next one? I've got a view towards the east up.
What I thought I'd bring up is we've been using the term fairly generally tonight called a nebula, and there's a cultural background to how that term came about. When the Greeks were looking up at the sky, now remember, Greece is a lot of islands, but it's also got a lot of very moderately high mountainous areas too. And the higher they were up in the up off the sea level, the more objects in the sky they could see, or the more questions they had about what they were seeing. And there were a lot of things that looked cloudy. And so what they did in Greek, when they called something a nebula or it was nebulous, it just meant, I don't know what it is. It's a mystery to me. So we'll just use that term as a scientific label of something you didn't quite know what it was, but it was not a pinpoint of light. And even at the time of Edwin Hubble, when he was first investigating light back in the 1920s into the 1930s, when he was investigating Einstein's theories of both mostly relativity, but they were getting a little bit into quantum mechanics. Relativity is the physics of the large, and quantum mechanics is physics of the small, down in the atoms. And so there were 2 people competing with each other to study the rules that had come out around 1910 into 1915 about physics generated by Einstein. And one was Father Georges Lemaitre, a Jesuit priest in Belgium, and the other was Edwin Hubble. And what happened was Hubble was trying to look forward and see what was going on in the sky, and Lemaitre actually wanted to say, well, if all these relativistic predictions say that the sky is expanding, that the universe, the space between objects was expanding, what did it do? What was it like before? So he started tracking the dimensions of the movement that he was seeing, while Edwin Hubble was looking at things from the going forward part. And he was trying to use things in our galaxy that we use to measure distance. That's when he looked at the Andromeda cloud. It was just a cloud, as far as people thought, in the middle of the Milky Way galaxy. But he noticed that when things are moving in space, there's a thing called a redshift. The spectrum of them shifts towards the red side of the spectrum. And he noticed by a couple of stars that he examined that should have been a certain distance away by those rules, he computed those rules to be in the millions of years, millions of light years away. And that was impossible because we knew the size of the Milky Way. We were pretty sure about it from the gravitational stuff. Meanwhile, Father Lemaitre was working backwards. He finally worked back that the whole universe came from a single spot, the cosmic molecule, as he was calling it. And so what he said, space is expanding, but everything in space is sort of like the raisins in raisin bread as it's rising before you bake it. The raisins aren't getting any bigger, but the space between them is getting bigger. Meanwhile, Hubble was saying, this stuff's moving away from us very fast. And it's not within the Milky Way. There's other galaxies. So all over this one word, nebula, about what was the galaxy that we now know as a galaxy doing, that Lemaitre and Hubble both explored both ends of it long ago, and what was the future. And as a result of that, that was in 1929 when Lemaitre came up, or the 1920s when Lemaitre came up with this cosmic molecule idea. Pope Pius XII in 1947 wrote him a letter saying, congratulating him for proving the existence of creation. And he wrote, and if you can imagine this in that era, a simple priest writing back to the Pope and telling him, don't mix my physics with your religion. Because I didn't say anything about a creation. I just said things can go back to a point where they were very small, where everything was very close together. So that was pretty brave for him. Meanwhile, Edwin Hubble went and totally changed the world's knowledge of what the universe really was, all over the term of what was that nebula up there, a cloud that nobody knew anything about. Well, we've used that term nebula now for a lot of the other things we've looked at. We've looked at things like Orion. That's what's called an emission nebula. It's one of the four kinds of nebulas, of true nebulas. An emission nebula means it's putting out energy because there's hot stars in it to make it ionize like a neon sign. Or it could be a reflection nebula. It's close enough to a hot star to reflect the light, and it looks bluish instead of red, but it's not hot enough to actually emit its own light. It's just reflecting light. And then there's dark nebulas, which the Horsehead is, and which it's in the area where Rick is going to try to go and look for the Flame Nebula. It's very close to the Flame Nebula. So the Flame Nebula is emission. There's a bright star right next to the Flame Nebula called Alnitak, the left belt star in Orion. And, or the bottom, it's actually kind of the bottom in that figure where, oh, Jim's rotating around. Okay, the left star in the belt of Orion is called Alnitak. And Alnitak is a beautiful double star if you look at it, if you with enough power, but right off the side of it is the Flame Nebula. Well, the flame is emitting light because the heat or the energy from Alnitak is lighting it up a bit. And down below in the lower part of that picture, you can even see the glow of the Orion Nebula, which is an emission nebula. In that area where that bright star is really it's a four-star complex called the trapezium that we can see is two of those two stars in the trapezium are double stars, so there's 6 stars in there. They're so hot that we started looking for planets there, then we realized that it's not livable. Within 5 light years of the Orion Nebula, the radiation is so high, any life as we know it could not survive in that area. So it's even if there were rocks, they're not going to be livable planets in that area. But it's a nebula, and it's called an emission nebula because it's emitting light because of the heat. So just that simple word nebula, meaning I don't know what it is, we really know what these nebulas are now. But we still use the old Greek term for something unknown.
Excellent. Thanks, Jim. That was a good discussion. Yeah, we've got all kinds of different terms, and we try to, you know, especially when we're doing star parties, and you got people looking through the telescope to try to explain it in such a way that they can understand what they're looking at. I mean, I'm amazed that you know, what some of these early astronomers were able to come up with and theorize, you know, and when Galileo first turned, a spotting scope, made it a telescope and looked towards the heavens in 1610. Ever since then, we've been getting more and more data and information about the night sky. But these guys were just amazing. All the, previous astronomers and the mathematicians and things like that were able to actually figure out what's in the night sky. It's just amazing.
Yeah, one thing that's not known or misunderstood about Galileo, some people think that he invented the telescope. Not quite. It was invented in the year previous to him getting one, but he heard about it. But everybody else who'd heard about it only thought about it in terms of military applications, being able to see troops across the field and what they were doing. When he heard about it, he said, well, I want to make one of these. I want to look up at the night sky. And so he put one together himself. He built it. And one of the first things he looked at was Jupiter. And so he was the first human being to see, Jupiter like that and see its 4 primary moons. That's why today we call those the Galilean moons, because he discovered the moons around them. Jim, I'm working on the flame on the Horsehead right now. Do you want to show everybody where it is?
Yeah, so just kind of zeroing in on Orion. So again, we are looking in the belt of Orion. And so if you look to the south, again, you'll see Betelgeuse, which is an orange red supergiant, and Rigel down here in the feet, and in between is the belt. Before, where we were looking was down in the swords. Now we're going to be looking right in this area, adjacent to this star, and you'll start to see some of the nebula coming up, flame and that kind of stuff. And that's what Rick's going to have in his telescope. It is one, these are a little bit hard to see visually, but with the camera, they just pop. I mean, they are just absolutely gorgeous. So Rick, you can take over the share whenever you're ready.
One of the challenges in photographing this object is that star in the belt, Alnitak. It is very, very bright. And it can really overpower the image. Fortunately, I have a good camera with a good filter on there, which knocks it down a little bit, but it's you will see it in the image. It's very present there. And I need about 80 more seconds. I should have it up, and I'll warn everybody. I took this. I'm shooting this one off the cuff here, so we'll see how well set I have it.
And as Rick was saying, a lot of imagers, if they're going to do some serious imaging of it, they will put the star just outside the field so that they're able to get the nebula without the starlight.
Yeah. Sometimes if they just want the Horsehead, they'll frame it so that star's outside of it. Usually it's framed with the flame nebula also, but
right.
It really is a very pretty region of space, as you'll see here in a minute.
If you have binoculars and you go out and look at those 3 belt stars, Alnitak is the left one, as we look at it. Alnilam is the middle star in the belt, and the far right one is Mintaka. If you look at them, they're all really pretty double stars when you look at them. I think even with binoculars, you can actually see that there's 2 stars in that spot where each of them are. They're nice. It's nice to look around in that area because you're not very far removed from the Milky Way, where there's a lot of activity going on. Milky Way passes nearby. The winter Milky Way passes nearby Orion, and so it's not like an empty area. It's a little bit populated of objects.
Yeah, and as Jim mentioned, especially if you can get out to a dark site in the summer, the summer Milky Way is usually very prominent from a dark sky, and you'll actually be able to see the band of the galaxy arcing overhead, and it'll come out of the south from Sagittarius and arc up to the north through Cassiopeia, and that's basically you're looking at the arm of our galaxy in towards the center, arcing across the sky.
The other thing I was going to note to everybody too is this whole Orion region is a popular area to photograph with a normal camera on a good tripod and everything, because there is nebulosity on this whole left side of Orion. There's a big long loop of nebulosity running along that whole side. There's stuff all over the place there. But
That part,
I'm ready to share.
yeah, that part of space is very rich in hydrogen,
Yeah.
in gaseous hydrogen that isn't quite dense enough to form stars. So it's so thick it's even got a name for the band up the left side as you're looking at it. It's called Barnard's loop, and it's just a loop of hydrogen. It's very thick and red if you get it just in a regular camera. It's a nice vision if you got that big a field that you want to look at it. In the summer, when you look at the Milky Way actually it's not just a single band. It's an upper band that's one arm of the Milky Way, and down below is another arm. And the Cherokee teach their children, if they're afraid, that those two bands of stars are really the arms of the Creator protecting them, so nothing bad can happen to them.
So
Rick,
everybody,
you
there
got it,
we
Rick.
go. I apologize that it is upside down. That's just the orientation of my telescope at this moment, and this software, I can't flip it around for you. But over here on the right is the Flame Nebula. It does look like it's, on fire. It's all these dark dust lanes causing that. Here is that bright star on the tack, just trying to blow everything out. And then here is the Horsehead Nebula. It itself is a lane of dust. What's really pretty, when this whole nebula complex is given more attention, this nebulosity above it is just gorgeous. It almost looks like summer rain clouds, and rain is coming down from it. The way that looks is just gorgeous up here. And you'll see this ribbon of nebulosity runs off to the left here in this image and goes off that way. So it's a very pretty region. And let me zoom in on the Horsehead for you there. I can do that even though he's upside down. And you can really see some of the structure in there. Now, as
we talked about earlier, that's some of the dark nebula.
Yeah. Now, as you'll notice here, as I zoom in, you are seeing some, pixelation, some noise in the image. That would go away as I took more and more images. The software can process out that noise looking image to image. And that's one of the advantages of shooting more images over time, is all that goes away and you get a cleaner image. But for one image, that's not bad.
No, that's gorgeous.
Yeah, it is.
No, it's the advantages of a 24 megapixel astro camera.
Exactly. Rick, you think you can do M45, do the Seven Sisters?
Oh, sure. What the heck?
All right, why don't we try that one, and then we'll make that the last one, and we'll finish up with that. We're glad everybody hung around with us. There's some great views. We do, even though we're back into doing star parties in person here in Tucson, I want to keep doing the virtual star parties to be able to share this with anybody that right now might be too cold to go outside, or too cloudy, or too much light. So it's just a good opportunity. And we, this will be on our Facebook page, and then tomorrow I'll have it up on our YouTube channel as well. And just before we quit, I'll share those addresses with you. But basically, if you just search for Tucson Astronomy in YouTube or Facebook, you'll find us just fine. And we do have, if you're in the Tucson area, we do have a calendar on our website. The website's just tucsonastronomy.org. But we have a calendar there, and we'll also have links to this virtual star party, as well as some of the past ones are posted on there as well. So we've had a lot of fun. It was a bit of a learning curve when we first had to pivot due to the pandemic, and we wanted to get into this. We chose to just do it on Zoom since that was the easiest way for us to share the images and stream it to Facebook. And I think it worked out pretty well. There are other ways to get the images out, but I think this is a good way to do it, and it works well for us. Sometimes the audio gets a little bit tricky. Heard some popping noises and things like that sometimes when Rick and Jim were talking, and being outside and maybe a slightly weaker signal makes it a little bit harder, but for the most part we're able to share the images. We did one where we actually fired up our 9-inch refractor out at our dark site, and one of our astronomers was using that, so that's kind of fun to be able to use it. So the last one that,
give me a few more seconds. This is a quick one because the exposure time is nothing.
yeah. Yeah, so the last one that Rick's going to show, and we had somebody had mentioned the Seven Sisters, or the Pleiades, and so it's kind of a cool open cluster. There's some nebulosity, so they speculate that the nebulosity is actually between us and the cluster, but it's kind of, on a telescope, if you have much for magnification, all you can see is just a couple of stars, but Rick should be able to show you a nice wide field view of the Pleiades.
I'm working on it.
And we are still seeing your screen, which is fine. Rick.
Oh yeah, you're seeing it come in. It just popped in the folder there. Yeah, let me see if we get a little bit. It's going to be kind of wonky color because I have a filter on my camera that's for nebulas, not stars, but we might be able to pull out a little bit of the nebulosity here. I just look kind of green. Well, if you look closely, like around the star over here and the one over here, it looks a little cloudy. With the proper, exposure techniques and everything, you can pull out some bluish nebulosity out of this. You're getting green because of this filter I have on my camera right now. But this nebula actually isn't associated directly with the Pleiades. It's actually some loose nebulosity that is between us and the Pleiades. So the Pleiades are shining through it. Now, Jim could fill in some of the mythology around the Pleiades better than I can, but the one story I like about the Pleiades, these are of course the Seven Sisters, and Zeus put them over here a good few arm lengths away from Orion, because Orion was known as a woman chaser, and Zeus didn't want Orion getting his daughters here. So.
Well, and another interesting story about Greece didn't have telegraphs, telephones, and other means of communications when these myths were coming up. And it's a big country. And so there's nuances to the stories. And in one of the stories, the Seven Sisters were the daughters of the goddess of the moon, of Athena. And she loved her daughters very much, but Zeus put them up in the sky to get them away from Orion, who was chasing them on the ground. And so he puts them up in the sky to make them safe, but they were in another part of the sky. And the goddess of the moon was so upset about that, and Zeus was her father. And so she complained to him that she couldn't be anywhere near her daughters. And so he moved the Pleiades to right where they are near Taurus, so that the moon goes through that path that's roughly the same path as the zodiac, and so that at least once a month she could spend a couple of days with her daughters. The moon comes very close to the Pleiades a couple of days every month. Or if you believe in some Plains Indian stories, those are actually 7 women in a Native American tribe that were growing and loved to eat onions. And it smelled so bad that their husbands drove them out of the tribe. And they started crying, and the Great Spirit put them up in the sky.
That's a good one too, Jim.
Oh, and there's another one more near the West Coast, that there was a battle of some sort between a couple of clans, and 7 of the very young boys, and one of them were made orphans. Well, it was considered they were considered to be of lower worth in the tribe, and they were so badly treated in the tribe that they ran away, and they were adopted by a pack of wolves who treated them well and took care of them and liked them. But the Great Spirit thought it would be better if they were not associating with those kinds of animals, and he put them up in the sky. And that's why you hear wolves howl now, because they missed the 7 boys.
Interesting. So where we're looking in the night sky is basically in Taurus, the bull. So it's pretty high up in the night sky. The Pleiades is right in here. And so if you were to, again, before we were looking at Orion to the southwest, and now this is a little bit further west is where the Pleiades is. And that's it right there. All right, let's go ahead and wrap things up.
Yeah, Jim, I thought one thing I could do real quick is I still have all the objects up here on my screen. I could run just back quickly through them for everybody to remind everybody what they saw tonight.
Yeah, that's a good idea. And someone did ask a few minutes ago as to whether we could zoom in a little bit on the flame. So I don't know if you can do that when you bring it back up.
On the which one?
On the Flame Nebula.
Oh, yeah. Can do that. Oh, so again, first thing we looked at tonight was the Andromeda Galaxy, stretching out here across the whole screen. Next was this open star cluster known as the Pinwheel. The M81 and M82 brother galaxies sitting here. The Great Orion Nebula. One thing to note that I didn't note earlier was we actually had a couple satellites come through. You'll see these staccato lines coming through. It's not a straight line because I was doing such short exposures. It just got a little piece of it each time it did an exposure. So that's some satellite tracks coming through. The Rosette Nebula. Thor's helmet. The Seagull Nebula. Come on, get over there. Hold on just a second. Oh, and there is the thing. And let me zoom up on the, got to get my controls here. Can zoom in on the flame there for you. Yeah, it's really an interesting thing to look at too. The Horsehead gets all the press, but I think the flame is one of the most unusual looking structures up there.
Yeah, I mean the dark nebula is so dark, and you can see a lot of structure in the actual flames.
And Rick, it's also got the alternative name of the tank tracks, because it looked like the treads of armored personnel carriers that went through space.
Yeah. So last thing I want to say is, again, I encourage everyone to go out and look at the night sky. If you own a pair of binoculars, go out and look up. You'll be surprised at what you see.
Yeah, well, thanks, Rick, for holding down the fort with the images. They were
Jim,
great. And, yeah.
Everything just came together.
No, of course it did.
Yeah, I know. But if I can I just like to share one picture,
Sure.
one image. Let me try to share screen, grab it up. I just sat here looking at it and said, well, maybe you could align yourself after I fixed 2 broken cables and a dead controller on it. And I told it to go to Orion and it went dead straight on. That was in the center of my screen when I told it to go. That's what I was working for all night. The 4 bright stars in the very center is the trapezium, and the red that's on the outer parts is the hydrogen gas in the area. But you'll notice different colors in there. Some of it is because of reflection, others is part of sulfur, silicon, and some other residue from prior supernovas that happened in that area. And right in that center area, right in that cloud, the cloud is so bright we can't see 1,500 new stars that are probably less than 10,000 years old in that area that are being formed. So I finally got one in.
All right. Very good. And it's a good one.
That is, by the way, 1.9 seconds of image. It takes my camera only 1.9 seconds to bring that much out. If I put it up to about 2.5 seconds, it'd almost fill the screen. But the center would be blown out by the intensity.
Nice. All right. Well, let me, I'm going to grab the screen and just show everybody the, where we're at as far as if you want to get to us on Facebook or the YouTube channel. Again, just search for Tucson Astronomy or Tucson Amateur Astronomy Association. I did just put in the chat on Facebook that our next virtual star party is April 22nd. We'll be going from 8 to 10 p.m. Tucson time. And I did put an event out on Facebook. So if you want to follow that, then you'll be notified if we have any weather issues or things like that. But we typically try to get them in. So any parting quick comments from Jim or Rick?
Yeah, I really loved the way you guys tap danced and talked and showed and explained things so well. I slowed down a little bit when I was fixing things, just to listen, Jim, to some of the things you were talking about and Rick explaining his wonderful things. I had some nice stuff I could have shown, maybe, if I'd fixed things soon enough, but I had a couple, like I said, a couple of cables and a hand controller die. But they're back.
All right. No, that's fine.
But thanks for watching, and please, everybody, when you walk out, look up. If you look up, there's a wonderful, that's your home universe up there.
Yep, exactly. All right, Rick.
I'm good. I hope everyone has a good evening and the rest of the weekend, and we hope you all join us if you're in Tucson at one of our live events here in Tucson, or join us for our next virtual.
Absolutely. All right. Well, thanks everybody, and we'll go ahead and stop the stream here, and maybe we'll see you at the next one.